Welcome to, I hope, another exciting video. In this case, part one of my Information Technology Thoughts Theory series. In this video, I'll be discussing if there is life in big NUMA and why is it so important for companies like IBM to continue to focus into big NUMA servers. This is not going to be a technical presentation, but for those who are not familiar with NUMA, NUMA is non-uniform memory access, where the memory access time depends on the memory location relative to the processor. While this technology is present in x86 to an extent, I wish to mainly cover it in big NUMA servers, which represents the IBM Power, HP Superdome, Fujitsu, and old Sun Spark servers, which did support 4 or greater socket-based server systems. In order to get an idea of how large this market segment is, in FY21 the overall global server market was about 84 billion. Thus, the 4 or more socket system sales represents about 17 billion of this value. It should be noted that in terms of numbers, that is server numbers, the share of 4 or greater socket systems is minuscule. Yet they represent about 17% of the total server sales by revenue. While the current server market trend is certainly focused on distributed computing architectures, often very loosely coupled, based on scale-out architectures using commodity servers, there is still a significant amount of value in big NUMA iron. This slide, which is a IBM marketing slide, and you should probably take it with a grain of salt, is an estimate of what IBM feels the market is like. IBM estimates that the 4 or greater socket market is, as you can see here, out to 2025. The drop between 2020 and 2021 is caused by EOL of server architectures from both IBM and HP, but this is estimated to recover by 2024. It must be noted every time a major vendor replaces an old server range with a new server range, Moore's law kicks in and revenue drops, even if the amount of CPU compute power sold dramatically increases. The major players in the big NUMA market is IBM's Power 10 based systems, which is the main vendor I shall cover in this video. In many ways, along with Fujitsu, this is the most conventional big server architecture, with the CPU itself being a critical differentiator with this server range. The HPE Superdome server is one of the other major players in the big NUMA market, although in many ways it is one of the more unusual players along with the Oracle Exadata system. In HP's case, it's based on blades, with the key differentiator being the Superdome inspired interconnect. I'll not cover the in-depth architecture of the system here, but may come back in a future video, as the architecture of the HP Superdome Flex servers is rather interesting. The other unusual player in the high-end server market is Oracle's Exadata systems. This, like the HPE Superdome server, is all about the interconnect. The CPU architecture is x86 and it runs Linux, so Oracle has no real competitive advantage in those all-important areas. The interconnect is an interesting technology which gives this server a number of advantages, but compared with the Superdome interconnect, it's not really a significant technological advantage. The major advantage in this is that it is in effect an Oracle database application server, and in that role it has real tangible benefits to customers in terms of reliability, security and scalability, which are all high marks or hallmarks of the high-end server market. But a general purpose computer, this is definitely not. Oracle also has its M88 series of servers, which are based on the Cray architecture which Sun purchased back in the late 1990s. It, like IBM, is a traditional big server architecture based on its CPU to give it its critical competitive advantage. Oracle also has a range of 4-socket CMT servers, the T8, which falls into our grouping of big servers just. This is based on the Sun CMT CPU architecture, which provides 32 to 128 cores in a 1 to 4 socket server. Each core may not be that powerful, but there are an awful lot of them, and it's an interesting technology to consider in this segment of servers. Using the same CPU architecture as Oracle, Fujitsu is also a player in the space. This is a very interesting vendor, as Fujitsu has a large facility manufacturing its computer systems, which I have no doubt it will wish to continue. Thus, I suspect that this will be very much a long-term player in the big NUMA market. A good question to ask ourselves is this does this market segment have a future? Based on the roadmap presented by IBM, it seems that IBM at least feels there is a future, and there is a very good reason why IBM does feel there's a future in this segment. We can also see that Fujitsu feels there is a future here, with their M12 servers having a roadmap which moves out to an incredible 2034. However, this chart does not show any new servers beyond that, only the EOL dates, but considering the date 2034 is a long time, that's expected. But there is also an interesting point. The last enhancement is scheduled for 2026, so there will be continued development in the new phase. So I personally believe that Fujitsu will continue in this segment for a variety of local reasons. HP also sees that there is a future, at least out to 2025 for the HPE Integrity Superdome systems running HPUX. However, I must admit, I found it quite surprising that HPUX is still a thing today. But anyway, it certainly is. And while I consider it an old operating system, there are a lot of fans of it. And I must remember back in the day when I used to sell HP systems, I considered the OS quite good. But regardless, the server that HP is selling, the HPE Integrity servers, will definitely have a future out beyond, but not with HPUX. So we can see that there are at least a number of large vendors which feel there's a future in this segment. The next question needs to be asked is, why do customers purchase these type of systems, as they are rather expensive? There are many answers to this, but some applications do run better in a single OS image rather than a distributed, loosely coupled manner. Let's look at the reasons IBM provides for customers purchasing their Power 10 systems. I'm not going to read all the IBM comments here, you can read it yourself, but looking at the high level, this is actually in essence correct. A distributed computing architecture, often very loosely coupled based on scale-out architectures using common commodity servers, can never be as secure as a big NUMA system with a tightly linked OS from a supplier like IBM. While the security-related differences may be minor, it does exist, and adding layers of software over your hordes of x86 commodity servers may provide some benefit, but at the cost of increased complexity. And complexity is the enemy of security. So overall, this is probably a very good reason to go down the big NUMA path. The next reason is to do with performance, and while it's true that based on an individual CPU, a big NUMA system will always give you superior performance than, let's say, an x86 in a distributed environment. When you use a dollar metric instead, then the difference does disappear and suddenly your price performance doesn't look so good. The main benefit of big NUMA systems is overall reliability and reduced costs related to outages. If you're running a mission-critical core system, this can represent a lot of money if the system should go down. If you're simply storing people's family pictures, then it makes no sense to get this kind of performance or reliability. This reason, superior performance for enterprise data, once again, when you're dealing with a tightly linked architecture between the hardware, hyperlayer and OS, you'll always gain significant benefit in terms of security, reliability and performance, but at a cost. Thus, the issue is that it will be a high cost. Once again, if you're running a mission-critical system, then this reason is very important and you will be prepared to pay the cost. However, if you're simply hosting a social media application, you probably wouldn't go down this particular path. This reason, flexible, efficient utilization, this is debatable, as in a distributed computing architecture based on a scale-out architecture using commodity servers. You can simply enhance your performance by adding servers, so you do have some level of flexibility. However, in practice, I have to admit, it is not as easy as it sounds, and it requires lots of software layers which suck up performance. But if you have an enterprise quality performance management layer on top of your horde of x86 servers, and you have a lot of unused servers hanging around, then that can give you actually a better solution at additional cost. However, once again, if you're dealing with a mission-critical application, especially one which requires a single OS image or very few OS images, Big NUMA does actually win out in this area. I think by now you're probably getting a feel for the use case for Big NUMA, and it's all about mission criticality. Well, reason number 5, trusted and proven foundation. Well, this tends to be more of a spin than reality. However, I have to admit, if you wanted to do software development on your mission critical Big NUMA server, this is very possible and is very safe, but it is very expensive. However, I'm uncertain if this use case is very common. I rarely ever saw it, and I sold big systems for 20 years. Nonetheless, a vendor like IBM will have a wide range of software which can allow customers to do most of what they need to do without going out into the marketplace searching for third-party software applications that may or may not work. As long as you have the cash, it's a lot easier, and basically easy can sometimes be very good, and people may be well prepared to pay for that easiness. Well, reason 6, Red Hat OpenShift container platform. Containers is an essential feature and a good feature, but it's not a critical reason to go down the Big NUMA path. Reason number 7, incremental application modernization. This is an interesting benefit, as it's a real benefit. If you're running a mission critical application which needs to have minimal downtime, the implementation of software enhancements can be a serious issue. This makes it a lot easier. However, the distributed architecture can also provide this in a far more messy manner. Once again, if the application is mission critical, this feature is critical. If it's not, then the additional cost is probably not worth it. Reason number 8, IBM Cloud Paks and Red Hat software. This is more of a software benefit which I won't go down, and I'm not quite sure how much of a real benefit it is for a user of Big NUMA compared with a distributed architecture. Reason number 9, innovate with an extensive container software ecosystem. IBM really pushes containers. I suppose considering its mainframe background and the customer base familiarity with mainframe LPARs or containers, it's expected. Once again, this is important if your application is mission critical. If not, a distributed architecture will do it at a much lower cost. Again, more messy, but it is going to be a lot cheaper. Reason number 10, comprehensive hybrid cloud management and automation. You can achieve this with a distributed architecture if you throw enough software at it. Oracle has one very excellent suite of applications which can provide this kind of benefit across a distributed architecture. However, I must admit, from using both a distributed architecture and a single image architecture, the results on a Big NUMA system is far more deterministic than a distributed architecture. Once again, if it's critical, go Big NUMA. If not, then save your money and go distributed. Thus, if we get to the chase, get to the core of the issue, if you are a financial services organisation such as a commercial or retail bank, you will almost certainly prefer to run your GL application or general ledger application on a Big NUMA system for a host of reliability, security and performance reasons. The same could apply to telco billing applications and a host of other mission-critical single OS image optimized applications. Core banking, core telco, core insurance all benefit from Big NUMA architectures and often are essential. On the other hand, these types of applications are incredibly mature and certainly do not grow at the same rate as those serviced by the distributed computing architectures based on scale-out architectures using commodity servers that people mainly talk about a lot these days. Thus, these kind of applications tend to be very boring to some people. They're also incredibly complex. There's an incredible amount of history to them, and because of their mission criticality, mistakes are absolutely disastrous. So a lot of people are basically scared of these kind of applications and prefer to move towards a distributed architecture running a file, repository application or social media application, but nonetheless they need to be serviced. However, besides the fact that they're mature, they don't grow particularly rapidly, they do represent significant revenue. Let's look at the revenue IBM receives from this class of servers to get an idea of why IBM likes Big NUMA. I've got actually a lot of different sources for the IBM revenue. If you looked before, I did have a number which was around about $2.8 billion. But these numbers come from IBM's annual results. Now, IBM does not break out these values, so you need to do a little bit of guesswork. Based on the FY22 numbers, it's probable that IBM revenue from power servers were slightly above $2.2 billion. It could be as high as 2.8 based on other sources. Now, we need to add services in with this, which could be about 1.5 billion as well. Of course, this does also apply to previously installed servers as well as current installed, but nonetheless is a number you need to consider. This totals just under 3.5 billion, or maybe even as high as 4 billion, and represents 24 or more of the overall infrastructure sales for IBM. So it's a big number for IBM. If these values are correct, then IBM represents about 2 to 3 billion of a 14 billion market, which I do find surprising. I would have imagined IBM to have a greater share, and I must admit the numbers I'm using are all over the place, and this guess may be not correct. However, if we go to the 8 core and above, IBM absolutely dominates this area because the 4 core area tends to be dominated by Dell and the HPE servers. On the other hand, you need to consider other factors. When you add in system software, database software, middleware, and financing for power system gear, it's quite possible that the power system line is worth over $5 billion a year to IBM. It should be also noted that the lifespan of a typical power system is at least 5 years and most likely longer, possibly even up to 10 years. So IBM may have an install base of well over $20 billion of power servers. The server revenue, or service revenue, which continues well after the sale, bumps this up to over 18 billion over this period, or even close to 20 billion. And when you include all the other software and services, this is a significant revenue flow for IBM. The other critical point you need to understand is most of these customers are running high-end critical core systems. These customers are the largest customers or company on the planet. IBM has points of contact at the CXO level with companies which properly represent the bulk of global business revenue. This is a critically important touch point for the selling of other systems and software and services which do not require big NUMA systems. By now you may be realizing why it's so critical for IBM to maintain its big NUMA power servers. It's a critical competitive advantage in selling services and consulting and gives IBM a competitive advantage against other service providers who lack a unique hardware platform already in place with those customers. Other companies, such as Oracle, can survive and thrive using its highly successful core software solutions, such as database. But companies which rely on services do require or should try and aim to have the ownership of the hardware and preferably the OS layer as well, in order to have an insurmountable competitive position or advantage over competitors in its install base. And that's something IBM does possess. While there are those who feel the big NUMA market is shrinking to oblivion, the big NUMA market is affected by Moore's law in the same manner as any other hardware technology. Yet if the revenues in FY21 was 14 billion, which is what IBM states, then this is not far off the revenues of the 4+ socket systems back in 2010, which was around about 18 billion, and even when you go back to 2000, which is about 20 billion. The fact that revenue is being maintained over a 20-year period, yet compute power continues to double each 18 months, is absolutely astounding. Thus, in conclusion, the big NUMA market is big, it's important, and it's important in ways that many people don't really consider. Thus, for a company like IBM, and even a company like Fujitsu, it's critical for them to own the hardware layer so they can sell other stuff all around it. It's a money-making machine. As long as those companies can maintain it, then they will continue to prosper and survive. And more importantly, from the customer point of view, Big NUMA provides something that a distributed architecture, at least today, simply can't provide in terms of mission criticality. Thus, this concludes part one of my video in information technology thoughts, in this case looking at the state and future of Big NUMA systems. As we have kind of come to a conclusion, there is a future for Big NUMA, but it's comparatively niche, but represents still a significant amount of revenue. Alle guten Dinge, kommen zu einem Ende.